Welcome to the second video of Unit A, Ratio and Proportional Thinking. This video covers complex fractions and unit rate. So the focus of this lesson is going to cover how you can use proportional relationships to solve multi-step ratio and percent problems. We're going to learn what a complex fraction is, how to simplify a complex fraction, and how you can use a complex fraction to solve unit rate. So we're going to have a review from the previous lesson, unit rate. First off, what is the difference between rate and unit rate? Then I want you to solve the following problems and round to the nearest 100th. What is the cost of green beans if you paid $2.13 for 16 ounces? And then I want you to tell me the unit rate for 4.5 meters in 15 seconds. So take a couple of seconds to do that. Pause if you need to, and then restart. So for the first one, I'm just looking for the textbook answer. Rate is a comparison of two different units, and unit rate is a simplified rate where the denominator is set to equal to 1. For the bottom problems, the first one is 13 cents for 1 ounce. Remember, you need to have the 1 ounce part in there. And the second one is 3.03 meters per 1 second. That's how you simplify them into a unit rate. So what is a complex fraction? Well, according to the textbook, it is a fraction with either a numerator or a denominator or both that are fractions. If that makes sense to you, awesome. If not, I have a simplified version for you. A complex fraction is fractions within fractions. The following are some examples of a complex fraction: 1/2 over 3, 2 over 1/2, and 1/2 over 2/3. How to simplify a complex fraction? Well, the first thing we need to recall is that a fraction is a division problem. We can rewrite any fraction problem as a division by the numerator divided by the denominator. In this case, 1/4 over 2 can be rewritten as 1/4 divided by 2. Then we are going to multiply the reciprocal of 2 to 1/4. The reciprocal means we are taking the fraction and flipping it upside down. When we do this, we're going to get rid of the division problem and get multiplication. And in case of a whole number such as 2, the denominator would be 1. So we'd flip it upside down and we'd get 1 over 2. Now we have a multiplication problem of 1 over 4 times 1 over 2. Then we multiply the numerator together and the denominators together, and we'll get 1 times 1, which is 1, and then 4 times 2, which is 8. So 1/4 over 2 is equal to 1 over 8. A simple way that we remember this is called keep, change, flip. Keep, change, flip is the method we use after we've rewritten the complex fraction into a division problem. It allows us to keep the first number that we have in the problem and then to change the division into multiplication, and then we flip the second number. Another way of thinking of this is that we keep the numerator the same, we're changing it to a multiplication, and then we flip the denominator. So here's the example, 1 over 1/2. We're going to rewrite it as a division problem to get rid of the complex fraction. 1 divided by 1/2, numerator divided by denominator. We're going to keep the first number, 1, change the division to multiplication, and then we're going to flip 1/2 over, and we're going to get 2. So now we have 1 times 2 to solve this complex fraction, and we do it, we get 2. Simple enough. We can use complex fraction to solve for unit rate as long as the fractions within our complex fraction represent units. So let's look at this example. Josiah can jog 1 1/3 mile in 1/4 of an hour. Find the average speed in miles per hour. That's the key right there. Because when we do this, we have to set up our rate of miles to hours. So we have 1 1/3 miles over 1/4 hour. So we've set up a unit rate there. I'm sorry, we set up a rate there. Now we can make a unit rate out of it and find out what his average speed is. The first thing we have to do is get rid of the complex fraction. Rewrite it as a division problem. 1 1/3 divided by 1/4. Now notice that we have a mixed number with 1 1/3. We don't want that. We want to have an improper fraction here. That way we just have a numerator and a denominator, no whole number. So we have to convert that back into an improper fraction. Now remember, when we do that, we have to multiply the denominator times the number out front, the whole number, and then add that to the numerator. So in this case, it would be 3 times 1, which we'd get 3, plus 1, and we get 4. So it would be 4 over 3. Now we can use that 4 over 3 to replace the 1 1/3 within our problem. And then we can apply the keep, change, flip practice to it. So now we have 4 over 3 times, we take 1/4 and flip it, 4 over 1. So we have 4 times 4, which is 16, and then 3 times 1, which is 3. You can leave it as 16 over 3. I'll accept that answer because I know you've done it right. But be aware that there are some problems that might require you to move it back into the mixed number, meaning that you're going to have to go from improper back to mix. You should know how to do that by now. If not, put yourself on the help board. We'll have a small little lesson to help you remember it. So Josiah can jog an average speed of 5 1/3 mile per hour. Alright, so here's my final example for you, and it covers how to solve a complex fraction that involves percentages. So I'm just going to jump right into it with an example, get moving. On Javier's soccer team, about 33 1/3% of the players have scored a goal. So we want to write 33 1/3% as a fraction in simplest form. We need to remember something about percentages. It's actually saying that that is part of 100. So we have 33 1/3 out of 100. That's a fraction that we have. So we can write the number 33 1/3 over 100. Any number that's in percent form, we have to write over 100 to get rid of that percent sign and give us that fraction that we need. So now we have a complex fraction when we do that. Then we just go through the same steps we've done in the past to solve it. Write it as a division problem. Then we're going to get rid of that mixed number and get that improper fraction, which is 100 over 3. Then we're going to replace that for our mixed number and use the keep, change, flip method. So we have 100 over 3 times 1 over 100. Because remember, when we have a whole number, it's actually that whole number over 1. That's what we're flipping. We solve it out, we get 1/3, and about 1/3 of Javier's team has scored a goal. So it's time to try it. I want you to try these problems on your own. Put them in simplified form. 2 over 2/3. 6 over 1/3. 2/3 over 7. 2/4 over 2. So take a couple seconds to try these, maybe a minute or two. Pause the video if you need to, and then restart it when you're done. Alright, let's check and see how you did. For the first answer, it is 3. You can see the steps I have out here. We wrote it as a division, used my kept, change, flip, and then I just simplified the last answer. 6 over 2 is equal to 3. Remember, we have some fractions like that we can simplify down to a whole number. For the second one, we have 18 as our final answer. For the third one, 2 over 21. Once again, all these were following the same steps as we've been doing. And then number 4 is 1/4. If you got those right, awesome. If you don't, put your name on the help board. I'll come help you. Maybe one of the experts can help you if we have any.